Hey everyone, in this video we're going to look at comparing fractions. So this is sometimes quite difficult because you're not always going to have fractions that have the same denominator. And what I mean by the same denominator is have the same, your whole split into the same number of parts. So if I have a look at, let's go back to our pizzas because pizzas are so easy. All right, so let's say I ordered 2 pizzas. All right, I've got my veggie and I've got my meat lovers. All right, so with my veggie pizza, I might have a party, and in that party 4 people are vegetarian. So we're splitting that veggie pizza into 4. Now in at my party, there are 6 people who like meat lovers. So I have to split my meat lovers pizza into 6 pieces. So let's say there's Betty, and Betty is vegetarian. So she gets a quarter of that veggie pizza. All right, so she gets her quarter, and let's say her friend Max loves meat lovers, and the meat lovers pizza, because there are 6 meat lovers, people who eat meat, Max only gets 1/6 of the pizza. So Betty gets a quarter of a pizza and Max gets 1/6. You can see that clearly Betty gets more of a pizza. She gets a quarter of the pizza because she only has to split between 4 veggie people, whereas Max has to split between 6 meat lovers people. So let me just change the color. So the bigger your denominator, which is the number on the bottom, the smaller the piece, because you're basically splitting a whole into that number of pieces. So let's take another pizza. All right, let's take Hawaiian. So let's say in this party, a huge family just rocked up and they all love Hawaiian pizza. Maybe they're from Hawaii and there's 10 of them. Actually, let's not do 10. Let's do 8 of them. It's a bit easier to split the pizza up into 8ths. All right, so there's 8 pieces of pizza. And poor Keanu, who's Hawaiian, he gets just 1/8 of that pizza. Did I say 6 before? I can't remember. He gets 1/8 of that pizza. So you can see from Betty, Max, and Keanu, he gets a smaller amount. So he goes hungry and he's like, oh, I want some ice cream, please. But poor Betty, she's like, oh, I'm done. I'm done with quarter of a pizza. And then Max is like, oh, I'm okay, but I might need some ice cream later. But then maybe there's another pizza that comes along. And this pizza is, I'm trying to think of, let's say, vegan. All right. And there's only 2 vegans in the group. 2 vegans. So it's split in half. And Shirley is vegan. And she's like, oh, great. No one else is eating my vegan pizza. So I get half of that pizza. So you can clearly see that Shirley is getting a lot more pizza than Keanu, a lot more pizza than Max, and a lot more pizza than Betty. And her pizza is split into half. So her denominator is smaller. So the smaller the denominator, the smaller share you get of a whole. So if we're thinking of comparing fractions, all of these are what we call unit fractions. So a unit fraction just has the number 1 on the numerator. So if I was to represent this on a number line, so here's 0 down here, and here's the number 1, and halfway is a half, and half of a half, which we'll learn later, is a quarter, and halfway between a quarter and 1 is 3/4. Now, half of a quarter is 1/8. Whoops, let me just rewrite that again. And this is going to be 3/8. Now we don't have to worry about that. 4/8. 5. This is going to be 5/8, and this is going to be 7/8. So that's a way of doing a number line, and you can see all the numerators are different. But if you think back to equivalent fractions, 1/4 is the same as 2/8, and 1/2 is the same as 4/8, and 3/4 is the same as 6/8, and even 1/2 is the same as 8/8. I'll just finish that off. So if we think about where everyone sits on this number line, there's Shirley at 1/2, and then we've got Keanu at 1/4, and 1/8. Betty, oh, I did them all at different colours. Let's do Betty here at 1/4, and Max was 1/6. Now, where is 1/6, guys? Oh my gosh. When you think about it, 1/6 is smaller than 1/4, okay, but larger than 1/8. So it's actually in here. All right, so 1/6 is there. So that's where Max is going to be. So you can see on a number line how they actually compare. So if we were to choose any two fractions, so let's compare the fraction 3/6 and 4/7. Where do they actually occur on the number line? So drawing my number line again, here's 1/2 in the middle. Now if I simplify 3/6 by dividing by the highest common factor, 1/6 is actually 1/2. So this fraction is here at 1/2. Now 4/7 is a little bit trickier to do. So think about where that falls on the number line. So 4/7, if we were to turn that into a equivalent fraction for 1/2, I'd multiply that by 3.5 and multiply the numerator by 3.5. So 1/2 is the same as 3.5 over 7. So 4/7, this number here, is actually larger than 1/2. So the only way, sorry, I shouldn't say the only way, the quickest way to compare is to think, well, where does it fit on my number line? Is it closer to 0? Is it closer to 1? Or how does it compare to 1/2? Is it less than 1/2 or is it greater than 1/2? Now, what I was saying before, it is probably the simplest way, but it's not the only way. So if I was comparing 3/6 and 4/7 and couldn't use that logic of the number line, what you would need to do is simplify both fractions. So this 3/6 becomes 1/2. And then you need to have the same denominator. So you think of a denominator that both 2 and 7 go in, or a number that 7 and 2 both go into, which is 14. And say, well, what did I do to get to 14? Well, I multiplied by 7. All right, so whatever I do to the bottom, I have to do to the top. So 1 times 7 is 7. And let's have a look at this other fraction. What did I do to the 7 to get to 14? I multiplied by 2. So whatever I do to the bottom, I have to do to the top. So 4 times 2 is 8. And we can see that 7 over 14 is less than 8 over 14. So it's another way of comparing fractions. And no matter what fractions you get, you can always change the denominator, because you can make fractions whatever you want as long as they're equivalent. So if I had something a little bit harder, so let's say I had 2 over 11 and 3 over, no, I might not do 3. Let's do 1 over 6. All right, so you're like, well, I don't know. You're kind of thinking, well, I could change. 11 is kind of close to 12. Maybe I can compare it that way. Maybe you think, oh, it's smaller because it's not quite 12. But you just change your denominators. You think about, well, what's common? What's a common multiple for 11 and 6? And you don't have to have the lowest common multiple. So what's the easiest thing to do when you're finding the lowest, oh, sorry, let me not do the lowest, but just a common multiple is just to multiply your numbers together. So a common multiple is 66 because all we're doing is comparing them. We're not actually adding or subtracting them, which would mean you'd find the lowest common multiple. So let's change them so they both have a denominator of 66. So what did I do to that 11 to get to 66? I multiplied it by 6. So whatever I do to the bottom, I do to the top. So I'm going to have 12 there. And then I do the same with my other fraction. All right, what did I multiply 6 by to get to 66? I multiplied by 11. And whatever I do to the bottom, I do to the top. So is 12 over 66 smaller or bigger than 11 over 66? So it is bigger. So we're 11 over 66 is greater than 12 over 66. Now I think when I was thinking about a 12th before, I may have got a little bit mixed up. But anyway, so just changing your denominator allows you to think about where they fit, because sometimes it's not always as straightforward as thinking where does it fit on the number line. And you can see here they're very close together. So just changing your denominator by thinking of a common multiple and just multiplying the denominators together will give you that common multiple. All right, let's think of one more. So let's do 5/7 and compare it to, let's do 14 over 15, even though that's going to be a tricky one. All right, so your common multiple, all right, because we're only comparing them, we're not doing anything else. We can just multiply our denominators. So 7 times 15. So what's that? 105. All right, so if you were doing that, you do your little thing on the side there. All right, so what did we multiply that 7 by to get to 105? We multiplied it by 15, and we multiplied the 15 by 7. Whatever I do to the top, I have to do to the bottom. All right, so you can see in my first fraction, I multiplied that 7 by 15 to get to 105. So I multiply the 5 by 15. So that's going to be 75. And then 14 times 7, so 98. All right, so it just allows you to see which one's bigger. So when your numerators are the same, we just say, well, when your denominators are the same, you just think about which numerator is bigger. And there we go. So 5/7 is smaller than 4/15. All right, bye guys.